Welcome. Today we're going to be taking a look at the notes worksheet entitled Verifying Trigonometric Identities Day 2. And so today what we're going to be doing is practicing some of the things we looked at yesterday. The good news is all of the developmental piece has been taken care of, and now it's just a matter of getting some practice and getting experience with this. So there are really only two things that you will be doing every time you verify an identity for me. Number one, you will be doing some type of algebraic technique, or number two, you'll be doing some type of substitution or replacement with an identity. And so what we want to do is really solidify some of those algebraic skills from first semester, and so that will hopefully flow a little better for you, and then we can kind of focus on seeing some of those expressions where we can go ahead and replace using identities. So let's try it out here. We're going to do it pretty open-ended initially, just getting some practice with the skills, and then we'll kind of dive into some actual verifications. So it looks like on your paper it should say simplify the expression using these algebraic techniques, and just different things that come up over the course of verifying identities. I would encourage you to pause the video, kind of maybe a back and forth here, meaning try it on your own, come back and see if you got it right. And then pause, try the next one, come back, see if you got it right. Anyway, let's get started. So multiplying fractions. Obviously don't see any fractions thus far in this expression right here, but I have tangent of x, cosecant of x, plus secant of x. And one of the techniques we talked about was very simply taking everything and trying to express it in terms of sine and cosine. Everything is connected to sine and cosine. So maybe something like this would do. And I guess the multiplying fractions piece that I was concerned about would be in this situation right over here. So focus on that part of our expression, and I'm hoping that something jumps out at you in terms of simplifying this. And if you remember, of course, a little middle school math here, sine of x on top, sine of x on bottom, they can do what is called cross cancel. And so let's see what that would lead us with. I see if those cancel out, I get a 1 over cosine x and another 1 over cosine of x. And I know I told you to work vertically. In this case, you can just kind of go where you need to go as long as you can follow your work here. I'm going to go ahead and just go right over here, and 2 over cosine of x, it looks like, as a common denominator there. We're going to be adding fractions in just a couple minutes, but that would be 2 over cosine of x. You could leave it like that if you want, just always thinking about connections here. 2 over cosine is the same as 2 secant. So something along these lines right here would be the exact same as this expression up above. And remember what an identity is, everybody. It's an equation that works for any number at all. And so if I put any number in for x and evaluated it here, it would be the same as putting that same number in here and evaluating this expression. All right, so sometimes it'll naturally progress towards something, and that's what I want you to get more and more comfortable with. Again, I'd encourage you to pause, maybe try B, combine two fractions together. All right, well, let's see. Either you're with me just in real time or you've done it already. But basically, I would say cotangent is cosine over sine. Tangent, everybody, is sine over cosine. So there are my two fractions. There will be plenty of situations where we want to go ahead and actually combine two fractions together. And so, basically, what do we need to combine two fractions together? And if you remember, of course, I will certainly need some type of common denominator. And so I'm hoping everybody would look at this denominator in this denominator and know that this is what's called the least common multiple of those denominators, sine, cosine. And so what you've basically done here is change the denominators of each fraction. This changed to this, and this changed to this. If you know how it changed, then what you want to do is change the numerator in the exact same way. I need to compensate. I don't want to change the value of this fraction. I'm just changing the form. If I change the denominator, I have to change the numerator in the same way. And I am hoping everybody would agree, from the original to the new and improved, it looks like we changed by multiplying this by cosine. So I would have to take that numerator and multiply it by cosine. And that would be cosine squared, everybody. So cosine squared of x, here's my plus. Plus goes in the middle. Same thing. How did I change the original denominator to the new and improved? And I'm hoping you would all agree that I multiplied this by sine of x. So I have to multiply the top by sine of x. Sine times sine, of course, is sine squared. Wonderful. That's putting two fractions together. Now, of course, what you want to be able to do in this case is see the identity. As I said, every step you will do either some type of algebraic manipulation or you will do some replacement using an identity. And this one you have to know. Cosine squared plus sine squared, everybody, is just 1. That was the big one that we developed yesterday. You know, that's perfectly fine right there. If you went a little further, again, sine in the denominator as a factor can come up as cosecant. Cosine in the denominator can come up as secant, maybe something like that. As I said, very open-ended here, just maybe seeing where it's progressing. All of this is good. This is a good answer. This is a good answer, etc., etc. All right, I'm going to box this piece up right here. That's just where it naturally led me. But again, if you saw something different, that's all right. No problem at all. All right, letter C, everybody. Split fractions. This doesn't occur a lot, but on occasion you might have one side sort of as one fraction and then the other side has just entirely separate terms. So one of the strategies you might employ is to split the fractions up. And I guess with this plus, and here's the key, guys, with this plus right here, this sine of x is a common denominator to this and to this. And so as a result, it goes under each one. So with plus, it is a common denominator. And so that's what I mean by splitting the fractions. Instead of putting them together like we did last time around, we separate them apart. And of course, everybody, let's take a look. Cosine over sine should be cotangent. And sine over sine should just be 1. I don't know, I think that's pretty good right there. Wouldn't go much further. I have seen students in the past try to go further with this, thinking of one of the identities from yesterday, trying to change this in some way to like a cosecant or something like that. No, no, no. Only with the squareds, guys. Only with the squareds. If you look back to yesterday's lesson, that identity with a cotangent and a 1 is only with cotangent squared. Okay, good. You do a lot of canceling common factors out on top and bottom. And you can shortcut this if you want, but I guess the way I would read cosine cubed, what does that mean? Cosine times cosine times cosine. Cosine squared, of course, everybody, is cosine times cosine. Now remember what it means to be a common factor. Our term has to be separated by multiplication and multiplication only, and so it is. And so the cosines can go. Same here, only separated by multiplication, so those are what are called common factors, one in the numerator, one in the denominator. And as a result, and I think you sort of knew this going into this particular expression, but this would be cosine of x. So cosine cubed over cosine squared is cosine. All right, perfect. So you can see we're kind of just working through some of the skills here. These are the ones as we employ some of the verification pieces you're really going to want to know and be able to work with. Okay, let's go to the next. I would ask you to actually put a little asterisk next to this one right here. You do see these compound fractions come up a lot. A compound fraction very simply means fraction within a fraction. Now this one is a pretty standard one. And here's what I'm thinking with this. This is just one fraction divided by a second fraction. And there are a couple different ways to look at it. Perhaps you've seen me do this little trick before. When I see something just like this, one over the other, I like utilizing the outside over inside trick. And so what that basically means is I multiply the outsides together. Sine times sine is sine squared. I multiply the insides together, and I end up getting cosine times cosine, which is cosine squared. So outside over inside. And again, this only works with really one fraction over the other fraction. And this looks good. I mean, that's fine right there. I would probably go one step further, just sort of utilizing one of the identities from yesterday. Sine over cosine for any degree, as long as they're the same, is going to be tangent. So sine squared over cosine squared is tangent squared. Absolutely. All right. Now that's the simplistic one for this. The harder one and the key, everybody, is going to be this one right here. So how would we work with this expression? There's no identity, so what we're going to do is a little algebra here. And the way we're going to play this out is change tangent and cotangent into its sine and cosine relationship. And so I get 1 plus sine over cosine, and then everybody, how about a 1 plus, and how about cosine over sine? So we have seen this first semester, and we worked with different types of what are called rational expressions with this. Now obviously we have some trigonometric expressions to pull this off. Now if you remember, the way I've taught this before is there's a very standard approach to doing something like this, and there's a shortcut approach to doing something like this. I've taught the shortcut approach, and the way I did it, first and foremost, I like symmetry there, so I put those over 1. It just sort of helps me visually. And what I have essentially is 4 fractions, 1, 2, 3, 4, within the overall fraction. Now everybody, what I would ask you to do is come up with the least common denominator for 1, 2, 3, 4 of them. So what would be the LCD of 1, cosine, 1, and sine? If you know that, then we're ready to roll. If you don't know that, then you're going to have to ask on how to pull that off, and I'd be happy to help you. But I would see this as sine of x, cosine of x. That's going to be our LCD right there. Sine of x, cosine of x. And so what we're going to do is multiply the numerator of this overall fraction by that, and then we're going to multiply the denominator of this overall fraction by that. So what I'll ask you to do is actually go ahead and draw a few arrows in so you get a sense of what we're going to do with this. Go ahead and distribute once, twice, thrice, and then a 4th time right here. And this would be a good idea if you haven't already. See if you can go ahead and multiply our least common denominator into each of those 4 terms and see what happens. And remember, the point was to kind of get rid of the denominators, the fractions within the fractions. And that should be accomplished with this step. So when I did this, I got sine of x times cosine of x times 1, which is that. Then a plus right in the middle here. And the beautiful thing about this, multiplying it into this fraction, is you have a cosine of x on top, a cosine of x on bottom. This cancels with this, and I'm left with sine times sine. And sine times sine is sine squared. So those cosines canceled out, which is what we wanted. As I said, we wanted to eliminate those denominators. Now everybody, I'm going to repeat and do the same thing on the bottom. And this is perfectly legitimate because I'm balancing it out. I'm doing this to the top part of the fraction, and then I'm going to take that same exact term and multiply it into the bottom of this fraction. Well, of course, everyone, multiplying it by 1 just gives us sine of x cosine of x. Here's my plus right from here, comes on down. And what happens in this last one when I multiply this into cosine over sine? Well, everybody take a look. Sine cancels, 1 on top, 1 on bottom, cross-canceling, of course, and I'm left with a cosine times cosine, which is cosine squared. And that's good. If you notice, again, it's not ideal at this stage, but it'll get there because now I've eliminated all of the fractions within fractions. Now this actually leads into step F, by the way. Our next order of business will be if we can sort of simplify this further. And one of the techniques that comes up quite a bit is factoring. Now we do have to be careful, of course. We do want to cancel out common factors that are on top and bottom. Unlike what we saw the last time around, these are not common factors at this stage. Remember, any term, any overall term separated by a plus or a minus, in this case, this term is separated by a plus, cannot be canceled out straight up with something on the top or bottom. So what we're going to do is factor. And I'm hoping everybody sees, look at the top, everyone focus on that top, and I see that there is a sign in both those terms. I'm going to factor out a sign, and if I factor out sine, I get cosine of x plus sine of x. Okay, now everyone focus on the denominator. Take a look, same thing. Look, 2 terms separated by that plus. What we're going to do here is focus on taking out the cosine. And if I take out cosine, from here, everybody, I'm just left with this. And if I take out one of the cosines from here, I'm still left with a cosine. All right, so that's going to come up. That's going to require some practice to be able to recognize when to factor. But in this case, it works out quite well because now if you notice, this cosine plus sine is the same as this cosine plus sine down here. And because this term is separated solely by multiplication, there it is, I'll even put that little multiplication symbol in, it can go. The whole thing, this term just cancels out. And I'm left with sine over cosine. And of course I would ask you this, what is sine over cosine? It's tangent. And so that expression that we started with actually is just tangent of x. This simplifies to this. All right. Good. Let's get some more practice with the next step there, just one more factoring technique. Always with these fractions, you're going to see this piece come up, and it's going to look quite a bit simpler on the other side, and you're going to ask yourself, how am I going to do that? How am I going to get rid of stuff? And chances are you're going to cancel common factors on the numerator and denominator. So look at the numerator, everybody. Two terms, one right here, separated by that plus. And do you see that there is a sign in both those terms? And so as a result, we're going to factor out sine. If I factor out sine from here, I'm left with 1. And if I factor out sine from here, I'm left with cosine of x. Down on the bottom, everybody, I just get 1 plus cosine of x. And the question, of course, becomes, is 1 plus cosine of x a common factor? And the answer is yes, because this term that we want to cancel out is only connected with multiplication. And if it is, it's a factor. It can cancel out with that. And as a result, that's what you're left with. So this big expression, all in terms of sine and cosine, is the exact same expression as sine of x. And that's it. As we talked about, there are really dozens and dozens of relationships amongst these 6 trig functions. And you can see, as complicated as this is, it reduces nicely to just sine of x. It's equivalent. All right, let me go to my next board here. And now, instead of me saying you're going to do this and you're going to do this, why don't we try utilizing some of the algebra there and some of the identities from yesterday and see if you can simplify a couple of these expressions. So again, open-ended. There's no other side of the equation at this point. That'll be the back side of your notes worksheet. So I would, again, do the same thing. I would pause, come on back, see how you did. Pause, come on back, see how you did. So I'm going to go ahead and do example 1A at this stage. And I am curious if you saw it. A lot of students over the years have sort of missed this one piece. There's so much to memorize. This one sometimes gets lost in the shuffle. But if you remember from yesterday, this is an identity. Tangent squared plus 1, everybody, is secant squared. So by using that identity right there, I can replace secant squared into tangent squared plus 1. So now it's secant squared times cosine squared, excuse me. And again, always looking to go further. What's a good connection with secant and cosine? Well, of course, secant really is 1 over cosine. So secant squared would be 1 over cosine squared. And so you would get something like that right there. Now, again, just good math, good middle school multiplying fractions. Cosine squared on bottom, cosine squared on top. What can happen to them? Well, everyone, they can cross cancel. And you're left with 1. And that's awesome. So all of that, no matter what number you put in place of the variable here, if you were to do this calculation, you'll always get the number 1. Now, if you missed it, if you missed that first step and didn't see this, you still potentially could have gotten here. I'm going to go a little quicker and show you. If you know this one, or if you've done it and you're good, move on to the next problem. But here's what I would think of, just in terms of this piece. Kind of taught you to go sines and cosines, and if you followed that, you might have done this. And then you would distribute once and twice. And of course, when you distribute it into the the cosine squareds would cancel, and you would get sine squared. 1 times cosine squared is cosine squared, and you would be left with that. And this one, you just have to recognize sine squared plus cosine squared is 1. And so, of course, no matter what, you end up with 1. All right. Now, everybody, letter B. This seems like it's just begging to be combined. I would take those two fractions and combine them together. Let's see how you can do or how you've done already. I'm hoping you would realize that the LCD here is just those two multiplied together. Cosine of x plus 1 times sine of x. Think how you changed the denominators from the original to the new and improved. In this case, it looks like I multiplied by sine. And so what I have to do is compensate and multiply the numerator by sine. And sine times sine is sine squared. Excellent. Here comes my plus in the middle. Now everybody see it, of course, on the right side. How did I change my denominator from here to here? Well, to me it looks like we multiplied it just by this cosine of x plus 1. And so as a result, everybody, I'm going to have to multiply that by cosine of x plus 1. And so I have cosine of x minus 1 times cosine of x plus 1. If you want, in fact, I probably should do this. I'll take this in 2 steps. So let me just make sure I have this perfect for you. So this would be cosine of x minus 1. And then again, what we're saying is you have to multiply that by cosine of x plus 1. And you would FOIL, by the way. And now I'll go down. If you were able to pull this off in 1 step, that's perfect. But if you FOIL, you get cosine squared of x. The outside and inside would cancel, everybody. And negative 1 times 1 is negative 1. Now we get this piece right here, cosine of x plus 1, sine of x. Now again, must see. No way around it, everybody. This part of the numerator. I'm not going to circle it on the board there, but I will just sort of highlight it with my pen. Sine squared plus cosine squared. That is 1. And so on the top, I get 1 minus 1, cosine of x plus 1 over sine of x. This seems where it's naturally going here. And by the way, of course, what is 1 minus 1 on the top? And when I take 0 on the top and divide it by anything, what do I get? 0. So as a matter of fact, as complicated as this expression is right here, as crazy as it sounds, no matter what number you put in place of x, perform those calculations, you're always going to get 0. Okay, good. Example 2 just says find 2 different ways. Just trying to open it up a little bit. One just might naturally gravitate towards. Maybe try to find another. Try to be creative with what you see using some type of identity. So I'll show you what I have, and you can compare and ask questions, of course, if you have them. So the way I saw this, just initially, one of the things that struck me is you end up getting cosine of x times cosine of x over sine of x. Now in this case, because it's multiplication and not addition, this can go under one or the other, and actually it makes no difference. But I would maybe treat this as something like cosine of x over sine of x. Something like that, just maybe making it a little bit better visually and allowing the algebra to take over there. And notice I haven't used an identity just yet, but I think I'm about to, because what is cosine over sine? Well, it's cotangent. So I've got cotangent times cosine. And that's not bad. That's just one that I saw with this one. Again, if you saw that, great. If not, look at the algebra there and see if that clicks for you. But cosine squared over sine is really this times an extra cosine, and there it is, cotangent cosine. Now the other one that I saw uses that identity, and it just comes up so much, I figured I'd utilize it here. Cosine squared, everybody, is this. So based on that real great Pythagorean identity, sine squared plus cosine squared is 1. So cosine squared, everybody, is 1 minus sine squared, and vice versa. So I don't know, I saw something like this, and I just played around with it a little bit. And this now, everybody, because of the minus, notice the difference. That's just great math going through this piece. This is a common denominator to both of them. So this would go under the 1. It would also go under the sine squared. So something like that. Just trying to give you some exposure to different things that you would see. What is 1 over sine? It is definitely cosecant. That one you have to know as one of the reciprocals. What is sine squared over sine? It's just sine. So again, just two different ways, that's all. No big deal there. Okay. Now letter B is an interesting one. One of them would come up quite a bit. The other one is not quite as obvious or prevalent. So I'll do the more obvious one first. When I see a 1 minus sine squared, chances are it changes to cosine squared. Not all the time by any means, but it's a pretty good bet. And so that's just what I saw as getting used to that piece, is just working with the 1 minus sine squared. By definition, everybody, 1 minus sine squared is cosine squared. Perfect. That would be one way. Not much more you can do with that, by the way. There's nothing with this fraction that's really going to be helpful to simplify. The other way is actually by treating this up here as something that is factorable. Now you've heard this phrase quite a bit in Algebra 2 and Pre-Calc 1, something that is what is called the difference of two squares. And this is exactly what it is. 1 is a perfect square, and sine squared is a perfect square. And if you remember, and again, it's not a big deal here because it doesn't come up a lot, but it does make this simplified. 1 minus sine squared theoretically would factor into that pattern right there. It is a difference of two squares and factors accordingly. And so now, as it factors, again, just convenient that that's the bottom, you can kind of see that this is a common factor on the numerator and denominator, and as a result, you end up getting this. As I mentioned, doesn't come up a lot, but there is a lot of factoring that goes into these identities, and so hopefully that helps. All right, so again, just a lot of good math. You can see the algebra is pretty high-level stuff, especially when you start using a lot of these trigonometric expressions in there. All right, let's go to that back side and now just try a few together and see how we're doing. So it says, know your identities in all the different ways to write them. Definitely with that 1 minus sine squared or the 1 minus cosine squared, that comes up a lot. This, number 2, is it says you can change each side independently until you match the left and the right. I would discourage you from doing that, but you can do that. If you just run into a brick wall, try playing around with the other side a little bit, maybe by working with that. Just be careful. Remember, it's not a conditional equation, so it's not like I do something to one side and then do it to the other. I work with one side independently. If you need to work with the other side independently, that's all right. And hey, listen, if you hit a dead end, just go on to the next problem, come back to it, just start with a different strategy. Hopefully you can get it to work. So we had some really good strategies on yesterday's notes worksheet. Obviously that's what we will be utilizing. There were just a couple other decent ideas. All right, everyone. So now it's just a matter of putting this together. I see at least 2 different ways to do example 3 here. So I would certainly encourage you to pause the video at this stage and try it. Try making the left-hand side equivalent to the right-hand side. And if you can do that, that'd be great. And if not, don't worry about it. You can see a couple things that I do. So here is the question. What did you do? I could see, I'm going to go through 3 different ways. And so if you see one, you're like, I've got it, go on to the next problem. But I'm going to go through 3 different ways to pull this off. So again, multiple paths. That is the beauty of these problems. And you know, whatever works for you, whatever your mind sees. Okay, well here's what I was thinking initially. This actually happens to be an identity. Secant squared minus 1. So if you remember the one from yesterday, now don't write this on your paper, but basically it's 1 plus, well actually it was sort of written slightly different, so just want to be clear. Tangent squared plus 1 is secant squared. And by the same token, if this moves over to the other side, secant squared minus 1 is tangent squared. And so as a result, I just saw that, just thinking about that relationship. I don't know if that's necessarily the best approach, but I saw that top as being tangent squared. Okay, so what I did is just initially, that was my first thought. I did that, and then everybody, I saw this piece. I know I'm trying to get sine, and so what I did, the next step is just put everything in terms of sine and cosine. So tangent squared is that. Secant squared would be this. So down on the bottom, it just turns into a 1 over. And I employed my little outside over inside trick. And you could probably see what's going to happen here. If you can shortcut some of these steps, but you get sine squared, cosine squared from the outside over cosine squared on the inside. These are going to cancel, and you get sine squared. There it is. Bring it down, you got it. Again, work vertically, make it happen. All right, so that was just one approach. I told you I saw 3. So I'll just kind of come over here. If you like that one, great. If you saw a different way, maybe I'll pick up on that in just a minute. But ultimately, it's what works for you. The second way that I saw everybody was the fact that this is a common denominator to each of those. And so I thought of maybe doing sort of a split with that and seeing what happened. So something like this, secant squared of theta. Oh, it looks like I went x on that last one. That's all right. Again, it's just the independent variable there. Sorry if the x fooled you, and then I'm changing it. So I'm just going to go x. Probably should have done that in the problem anyway, just to keep everything uniform for you. Again, sort of irrelevant. It's just the variable. So anyway, let me go ahead and do that piece over here. So secant squared of x, that, and then minus 1 over. And then I get 1 minus. And by the way, everyone, what is 1 over secant squared? 1 over secant squared is cosine squared. So that's how those two simplify. And this is one that just comes up so often. I'm glad it came up here. That is sine squared. And then that's it. Bring down the other side and you got it. 1 minus cosine squared is sine squared. So many different ways to pull it off. All right. Well, maybe one more way. Just curious how you pulled it off. I think I'm going to have to come over here. Sorry. So just trying to find some board space for you. Now, if you just use my initial strategy of just everything immediately goes sines and cosines, then maybe you did something like this. Again, not sure. Just trying to think about what I've seen students do in the past. And then, of course, what you would do, being a compound fraction, and these do come up a lot, is you would multiply everything by cosine squared. Cosine squared here, cosine squared here. And that would eliminate what we would see as all those denominators, this and this. So I distribute 1, 2, 3 times here. And I would do this times this is 1. This times this is cosine squared. And then this times this is 1. And of course, everybody, now that I have that piece, I'm back to where I was before. You can see all the overlap here. It is quite incredible how it's all intertwined. And there it is, everyone. Sine squared equals sine squared. Okay, good. So maybe you stuck with me on all 3 parts there. I'm just trying to give you some ideas. There's no one right answer. That is either the beauty or the issue with these. You'll just kind of have to figure it out. All right, let's go to 4. So example 4, everybody. Huge, monster expression on the left-hand side. Very minimal expression on the other side, and no plus as a matter of fact. So what that tells me is I'm probably going to want to combine these together. You've seen it before, and we'll definitely see it again. So what I would do, of course, is combine these together. How did you change the denominator, old to new? In this case, I multiplied this by sine of x, so I have to multiply the top by sine of x. And just sine times sine, I'll do right there. Now this one's a little harder. How did I change this denominator from here to here? It looks like I multiplied it by 1 plus cosine of x. So I have to multiply that numerator by 1 plus cosine of x. Now be careful with this. That's essentially 1 plus cosine of x squared. But with that binomial squared, remember it's really FOIL. So just be careful on that piece. We are going to FOIL that out. If I do that, I get sine squared plus, and then let's see what happens here when I FOIL this out. I get 1 plus 2 cosine of x's plus cosine squared of x. Ooh, this is a good one. We're starting to get into some of the harder ones here. So stay with it. Make sure you see sort of the algebraic step there. Haven't employed any type of identity just yet, but I'm about to. And here's the thing, and I'm curious because there are a couple different ways to see it. It is, again, all connected. But I would say there's something that really just jumped off the board at me. I have a sine squared right here, and even though it's not right next to it, I do have a plus cosine squared right here. I'm going to just connect the two. And what is sine squared plus cosine squared? Well, by definition, everybody, it simplifies to 1. So I'm going to write that 1 now, and not that. If you want to go ahead and put a couple steps together, you're more than welcome to. But that's what I'm seeing at this stage. Remember, you're trying to prove the equation is true. So please make sure you really you go through every step in a very comprehensive way there. All right, so now I would probably put those together, and so I get 2 plus 2 cosine of x. Bottom, everybody. Okay, and look where we have to go. I need 2 cosecant of x. Now let's keep the other side in our mind here. Well, 2 cosecant means I'm going to have a sign on the bottom, which is good. I have it. And I'm going to need a 2 on the top. I have it. But how am I going to get rid of this? This is not part of the other side. And as I have mentioned before, typically it comes down to canceling out factors. So did you look at the top? What is the common factor in that numerator? It's 2. So can that 2 come out? And when it does, do you see what pops out and will now cancel? This cancels with this. And I'm running out of a touch of board space, so I'm just going to say we have 2 over sine of x, which by definition, everybody, is 2 cosecant of x. All right, so if that one did not click for you, please go back and really take a look at it in detail there. A couple ways you probably could have navigated through this step. I like just the sine squared plus cosine squared. That's just 1. There it is right there, guys. And then it goes. All right, I'm going to do the last one here, and as said, really there's just practice with this. That's what it comes down to. I had mentioned I won't put this on a test or anything like that, but you see the inputs are a little different. This is that opposite input or the negative input. What that very simply does, and let's just take care of it, sine is what is called an odd function, and so what it does to change this to x, this goes to its opposite. So instead of a minus, it just becomes a plus. Again, not a big deal. Don't worry too much about that. So here's an interesting one. We've got the 3 primaries all connected in one fraction, and this apparently is equal to just tangent of x. So for any real number, let's see how this is going to work. Okay, so there's not a whole lot of algebra here. This, as a denominator, I wouldn't really split it up. That's probably not the path we want to take. I don't see any identities with this one or this one here, but I do see this. The only thing I saw, as a matter of fact, is that. And unfortunately, I've kind of now created, and you don't have to put those over 1. Some students like it, some students do not. But I'm going to go ahead and put that cosine of x over 1 as well, and then go from there. So now, everyone, you see it's sort of fractions within fractions, what is called a compound fraction. And what we want to do is get a least common denominator and hopefully be able to kind of clean that all out and see where it leads. So I'm hoping everybody sees with my 4 manufactured fractions there, the least common denominator is just that cosine. So cosine of x here, cosine of x here. Distribute 1 time, 2, 3, and 4, everybody. Okay, well when I do that, let's go ahead and distribute this times this fraction right here. And as you can see, cosines would cancel. And that was the point, of course, so we get sine of x. Then here's my plus, everybody. And I repeat, cosine times sine over 1. Nothing cancels, but that's okay. It's just over 1, so it doesn't matter. Cosine times sine, not much I can do except just say cosine sine. Okay, now over. Let's do it 2 more times here. Cosine times 1. Again, nothing cancels, so cosine times 1 is cosine. And then last here, I get cosine times cosine, which of course is cosine squared. Okay. Now just be careful about a couple things. I guess I would ask you this. Does the cosine cancel with one of the cosines here? No, definitely not. Remember, if it's separated by a plus at all, you cannot treat it as a factor to cancel out something in the other part of the fraction. So what you want to do, before you even decide, am I going to cancel, you have to factor. And so look at the top, 2 terms. Each one of those terms has sine in it. And so sine is what's called the greatest common factor. And if I pull out sine from each, I get that. I look to the denominator, everybody. And by the way, remember, always keep the other side in your mind. You knew tangent was sine over cosine, so there's our sine. Now let's take a look at the denominator. 2 terms. It looks like cosine is in each. And here's where we show it's working. Factor it out, and we get 1 plus cosine. Are these now common factors, this 1 plus cosine? Sure. It's separated only by multiplication, so it goes. And sine over cosine, everybody, is tangent. And we've got it. All right. So we're really starting to get into some higher level verifying identities here. Obviously, you can see that it takes a lot of practice, it takes a lot of experience, it takes great algebra skills, and the ability to see an identity when it shows itself. Obviously, I'll certainly help as best I can as you're getting that practice. Do those practice problems, and please ask questions and help each other out. And of course, thank you for listening to the lesson.